What's up everyone? Welcome to my tutorial again. In this tutorial I'm going to show you how to implement transfer learning in a very short way. In my previous tutorial I showed you guys how to implement the squeeze net, and our network, it ended up getting very poor accuracy. So let's increase this accuracy for the dataset that we have used, the image dataset for concrete cracks, by using a pre-trained model from Keras. So this is going to be super easy for you guys. Python these days is so much easy to implement in terms of deep learning, thanks to all the researchers included in the community. So let's do it. So model 3 equal to Keras dot applications dot, I think we're gonna use the Inception version 3 parameter. So version 3 model. So we can pass a lot of parameters here. So let's include top equals true, and we will be using the first layer of the model as our input. So before we do that, let's just see the model that we're using. So this is the model. This is a very big one, so we'll be using the first layer as the input. Oh my god, why it's so big. So the first layer will be using it as an input, and then the last one, so we have to remove that to modify the network accordingly to the classes we have. So we don't have 1000 classes, so we have only 2 classes. So we are gonna get rid of these and modify the network accordingly. So our base input is going to be, so model 3 dot layers 0 dot input. And then we have to declare our output. So we are going to get rid of some layers. So okay, which layers? Oh my god, if I just start counting from the start point of the model, so it's going to take a long time to do that, to count. So we can do it like -1, -2 this way. So to do that, let's declare our output. Base outputs is equals to model 3 dot layers, and this one is -2 dot output. So our final output is going to be layers dot dense, and we have 2 classes, and then base outputs. So finally, let's name our model. So our new model, it is going to be just keep it as new model equals Keras dot model and our inputs is going to be base input, and our outputs, it is going to be the final outputs. So I think our new model is ready. So let's run it to see if there is any mistake. I hope not. Oh, okay. What? Ah. So base outputs. Okay, so I have done a great mistake here. Okay, so we're done with that. Now we need to compile our model. I'm not going to write the same code again. I'm just going to get the code from Upward that I used. For like running the squeeze net. What is it? Okay, here. So we are going to compile our model. So it's no more named as model, so let's change it to new model. Can I compile it? Yes, the model has compiled. And then we have to feed our model. I'm going to feed the model here. I'm just going to take the source code from here that I did for SqueezeNet. Guys, please, if you are curious like what I've done in my previous tutorial, you can just check it out in my channel and see what I've done. I think that will be pretty much easier for you to understand what's going on here if you watch the previous video of mine. So here it's no longer model.feed, it should be new model.fit. Okay, you can see it has started running. I think it's gonna take a while to run. I think it's gonna take a long time because how can I tell you? It's because like I'm using Google Colab. I don't have enough power in the machine, so let it give some time. Or I can show you my previously run code. Okay, it has already come. Oh my god, the expected time is 24 minutes 24 seconds, so I need to show you guys in a different way. Let's upload a notebook that I previously coded. Just give me some time. I think here is the one. So actually this part here, like I did the same works that I have done previously to show you the implementation of the InceptionV3 model as transfer learning. So this is a previously done work. I mean the notebook, I've just loaded it, and so it is kind of like still running, and I'm not sure like how long it's going to take the time. So I'll just show you a previously coded one. So here you can see that like the accuracy here for the Inception version 3 model is like 99%, and with just only 5 epochs. I'm pretty much sure like if I run it like 10 or 20 or 100 epochs, it's gonna even get to 100% accuracy, and the validation accuracy is 86%. Whereas here in our case, like where we used the squeeze net, where is it? In the SqueezeNet case, you can see that accuracy was very poor. So the transfer learning, the pertained Inception version 3 network has significantly improved the accuracy a lot. So that's the magic of using transfer learning. You're gonna get a very good accuracy every time you do it in most cases. That's all I think. Uh, Thank you for watching.